Alright, we are doing 6-1, which is solving systems by graphing. This whole chapter is on systems. I really like systems. I don't know if that'll translate into you liking systems, but I think this is just really cool. Yeah, probably had a little bit of this in the past if you did a pre-algebra class, just at least looking at what a system is and maybe solving by graphing or tables. This first section is going to be solving by graphing. So kind of review of what you looked at before. So first, just some terms. If we have a system of linear equations, well, that word linear means we have to have a line. It has all kinds of words in there. Arr, if you're a pirate, ear, near, in, but line is going to be one of them. So we're talking about lines. And a system then is going to be two or more, so two or more lines considered together. Basically what it's talking about is we have a problem, and the problem has two different lines in it. The solution is going to be what point works in both lines, what point is going to fit both line equations. So the solution is going to be the ordered pair, and I'm going to throw an S after that word pairs because it could be more than one point that works, and we'll get into that several sections in. But the ordered pair, the ordered pairs for the points. That could be singular point or it could be plural again, that satisfy all the equations. And that is that. So first, I know a lot of us actually don't really check our work like we should. I've kind of been victim of that, to be honest. But here's how you do check your work, and you should. You'll probably get one token test question, quiz question, and say, hey, show how you check your work on this one here. Yeah, so you have to be able to do it if you want to get an A. But we have an X value and we have a Y value, and we want to see, well, does that fit both equations? So really, we just take both equations, put it in, see if it's still equal. So this is how I'm going to try to get you to show your work. First, copy the equation, or how I want you to show your work if you want full credit. Then put in the X and the Y. So I'm putting a 5 in for X, I put my 12 in for Y. And then kind of work through it step by step. So 12 equals still stays there, but now 3 times 5 is 15 minus 3, and then 12 equals 12. So you're just kind of showing each step to showing that the two are equal. And as long as you get one number equals itself, you know that that point works in that equation. So I would take and now do that same thing for this next one. I'm going to put a 5 in here for X. I'm going to put a 12 in there for Y. So you get negative 2 times 5 plus 12 equals 2. Now I do my steps one at a time. So order of operations, first I have to change that to a negative 10. Plus 12 equals 2. And I get a 2 equals 2. So because that point works for both equations, we know that that point is going to be a solution to the system. Now this next one, I'm going to have to kind of switch programs on you a little bit. I want to show how to do this by graphing. Graphing isn't my favorite way. It's a good, quick way to come up with an approximation, but there's cooler ways we're going to learn this chapter to do some other stuff. When you get to Algebra 2, you'll learn an even cooler way than what we get this chapter. So graphing calculator is easier than doing it by hand. If you're going to solve by graphing calculator is way nicer than trying to do two accurate lines and then figure out where they meet. And zooming in gives a more accurate result. I'm going to show how to do this on a Texas Instruments graphing calculator because that's what people pretty much always use, it seems, in high schools and whatnot. So first thing, turn it on. Your on button's down here in the lower left. And if you think somebody may have messed it up, you could do second plus 7, 1, 2. So second plus, the plus takes you to memory, and maybe second plus, and then 7 gets you down to reset. 1 is reset everything. 2 is, yep, reset it. So if you think somebody messed up your settings, you could do that. And now to graph something, you press this y equals button right up here. So I have y equals. And in example 2 there, we're going to plug in both of those equations. So the first one is y equals x. So our variable key is right there, this x comma t comma theta comma n. So my first equation is y equals x, and I could press enter. My next one is negative. You need to make sure you use this key here. The minus sign and the negative are two different operations on a graphing calculator. Then you have 2x minus 3. Enter. Now that I have those two lines, and if yours isn't a color one or whatever, the steps are exactly the same for TI-83s, TI-84s, Alright, then we can hit graph here. And we should see where those two lines cross, so our solution is going to be this point right there. Now with that, it's hard to know exactly how accurate is that. What I could do is I could hit trace, and up and down are going to change which line it's on. Left and right actually move it along that line. So it looks like I'm right about this negative point, I don't know, negative 1.06 and negative 1.06 for my x and my y. But if you want to be more accurate, you could press zoom. And zoom in is probably the easiest. Zoom box is cooler. But if you press zoom and then pick number 2, the zoom in, every time you press enter, it's going to zoom in centered where your cursor is. So I'm going to hit enter. It'll draw the line once here, second line. And if I zoom in maybe one more time, I'm going to make it a little closer to the middle, or closer to the intersection. Hit it again. Now as I trace, as it jumps from pixel to pixel or from dot to dot on the screen, it's going to be more accurate than when I was zoomed out. So right there, looks like it's probably pretty safe to say it's going to be at negative 1, negative 1. So my answer to that point then, or that system, is going to be the point negative 1, negative 1. And I'll quick write that down on a random scrap of paper. Wasn't planning for this. So by example 2 in your notes, you could do negative 1, comma, negative 1. And that's the answer. That's the solution to the system. For our second one, I'm going to kind of do this in a way that kind of shows the mistake a lot of people make. So I'm going to go hit y equals again, select both of those and press clear. Now I'm going to type in what we have for example 3. So I have x minus 6. I'd encourage you to do this on your graphing calculator also. Now we have this problem here. We have negative 1/3 x plus y equals negative 1. And that's not solved for y, so we can't easily put that into a graphing calculator. But what we could do is we could say, well, I want to add 1/3 x to both sides because it's at minus 1/3 x. That'll cancel that out. Then I also have to do it to this side. So I get y equals negative 1 plus 1/3 x. And you could, if you wanted to, write it in slope-intercept form, 1/3 x minus 1. I'm probably just going to leave it like this here as I punch it. Now two things. One, with these 84 pluses, you can actually use a fraction key. But if you don't have one of those, what's always safe is to take and put a fraction in parentheses. And that's what I'll do here for y2. So y2, I'm going to write negative 1 plus parentheses 1 divided by 3. Parentheses, and my x button. And now I have my second equation typed in for a line. Now when I graph this, this is where a lot of people kind of like, oh no, my graphing calculator's broke. They'll graph it and nothing, bummer. Often they'll graph it and nothing will show up. And here's why. That when we have our screen, when we did that last one, we zoomed in on this little part of the screen right there. You'll notice there's no x-axis, no y-axis. We have a little bit of a dot up here at the top center. But unless your line happens to go through that little point, unfortunately ours does, it kind of kills my example, but go so that you're not going to see anything on your screen at all. A way you can easily get back to the normal window is if you press zoom, and then number 6 is zoom standard. That'll take you back to where you have a negative 10 to 10 on the x and a negative 10 to 10 on the y. Alright, for this one here then, we want to find that point, so we could hit trace again and zip over here to the right and try to figure out what those are. And again, that's not going to be super accurate when we look at positive 7.58 with a little bit of rounding, 1.58. So to be accurate enough, I'm usually going to want people to be accurate to at least 1 decimal point, maybe 2. So I'm going to pick zoom, zoom in, and my cursor is where those two cross, or at least close to it, so I'm going to press enter, and I'll maybe do that a couple times. Enter. If you want to learn the other one, I hesitate to take the time, but here's the cool way to zoom. I do zoom, I pick zoom box. What you have to do is you pick your selection you want to zoom in on, but you have to hit enter in 2 opposite corners. So either those 2 corners or these 2 corners would work. So you can make your box starting right here. I usually try to make the box as small as possible, and kind of see, can I keep that intersection in there? Usually my box is a lot smaller than this, but you wouldn't be able to see what I'm doing if I made a super tiny one. If I do something like that, now my intersection is inside there. It's going to zoom in just on that part. So that's how I usually zoom in when you guys aren't watching, but zoom in works as well. And once I'm there, now I can hit trace, and now you'll notice that these X and Y values barely change as I'm moving along this blue line here. And I get 7.500, so my final answer then for this one, another post-it note, is going to be 7.5 comma 1.5. And because I zoomed in so much, you can be pretty much certain that those two are going to be accurate. Alright, now to the very last section. If you flip to that last page of your notes, we have this example here. John's ATV rental charges $80 plus $5 an hour. Butch's Backwood Bombers rents them for $20 and $25 an hour. How long would you have to rent to make John's a better deal? Essentially what we're looking at with these is if you have your graph, the one starts out at 80 bucks an hour, so I'll just put in 80 in here, but it doesn't go up real fast, it's just 5 bucks an hour. The other one starts at 20, but it's going up faster, it's 25. So we're trying to figure out what's that point right there. What's where it switches from this second one here, Butch's being a better deal. This Butch's is right there. Where's it switch from that being a better deal to John's, this other one, being a better deal. So that's kind of where we're going. So we could do X and Y. X is the amount of time. That's probably easiest. So if I say Y for John, these are both going to fit that y equals mx plus b. We have our slope, we have our y-intercept. Y-intercept for John is 80. That our graph over here starts with a y-intercept of 80. Now it goes up by $5 an hour. And so I'd have a 5x plus 80. So this would be my first line equation for John. And if we want to do the similar sort of thing, but for Butch, we'd still have that y equals mx plus b. But for Butch, he just started with 20 bucks. It's $20 to get out the door. And so we'd have $20 there for the y-intercept. And his go up $25 an hour, though. So once you had these two equations here, this one and this one, you could take and punch those into your calculator and then look for that point. And the x value of the point is going to be that amount of time you'd have the rental where one would be a better deal than the other. And y would be the cost at that amount of time. That's it for the section. Let me know if you have questions. I'm glad to help you.